This lesson is going to let you know about the properties that you will be investigating and using in Algebra 1. Most of them you are already familiar with from your pre-algebra and before days, but there are some new ones to algebra that you have not seen before that you will have to make a special effort to know. On this chart, we will be giving you the main idea, a variable example, and a numerical example for each one so that you have something to study off of. The first one we're going to start with is the associative property. The way I like to remember this is for the word associate, and if people associate together, then they're usually friends. This property has one for addition and multiplication. Right? So the main idea behind this one is that the parentheses move to other groups on the other side. So what this looks like in terms of variables, if I have parentheses x plus y parentheses plus z, on the other side of the equal sign, it will be x plus parentheses y plus z. Notice that the order did not change, just who is in the parentheses changed. So for instance, x and y are friends on the left, and on the right-hand side, y and z are friends. For multiplication, it's the exact same concept, just with a different operation. So with the variables, you would have parentheses x times y times z equals x parentheses y times z. And again, notice that the order is exactly the same, it's only the parentheses that are moving around. For the numerical example, just take the letters out and put a number in its place, and you've got the same process going. So for instance, if we have 2 plus 3 in parentheses plus 4, on the other side of the equal sign, it will be 2 plus parentheses 3 plus 4. Right? And both sides will yield the same answer. For multiplication, again, change the operation, and we can use the same number. So parentheses 2 times 3 times 4, 2 times 3 being in parentheses. On the other side, it's 2 times parentheses 3 times 4. So notice the 2 and 3 are friends on the left, and then the 3 and 4 are friends on the right. If you need another way to help you remember associative property, there are 2 S's in the word, and I like to use slip and slide to help you remember that, because the parentheses are slipping and sliding onto different groups. The commutative property is the one that you've been doing since elementary school, where we use the letter CO to help us remember what it's about, right? And for CO, it represents change, order. And once again, there is one for addition and one for multiplication. The idea behind this one is that the order on each side switches. So for a variable example, if we use x plus y equals y plus x, notice that the order changed, but the variables did not. And there are no parentheses in this one. Okay. For multiplication, it's the same idea, just a different operation. So we have x times y is going to be the same as y times x. And again, take the letters out and put numbers in its place, and you will have numerical examples. So for the commutative of addition, we would have something like 7 plus 5 equals 5 plus 7. And for multiplication, we could have something like 9 times 6 is going to give the same answer as 6 times 9. Now there is one in commutative property that students often get mixed up and don't quite know what to do with, so let me show you what that one looks like. If you have parentheses x plus 3, close your parentheses, and then plus 4. To make this the commutative property, what's in parentheses does not change. It's where the placement of the 4 is that changes. So the other side would say 4 plus parentheses x plus 3. A lot of students want to name this associative because they see those parentheses. But if you look in the parentheses, the friends are still the same on both sides. The order changed, not the parentheses. So just watch out for that one. The next one is the identity property. Okay? And the way I would like you to remember that, or to make it easier for yourself, is remember the word identical. Okay? When something is identical to each other, they're exactly the same. So the main idea behind this one is whatever you begin with, you're going to end with. So you're going to have the same identical answer to whatever you started with. Now, it's a little different for each operation. In addition, the way we end up with the same thing we started with is we add 0. In multiplication, we can't multiply by 0. That doesn't give us what we started with. We have to multiply by 1. So you do have to remember the differences in what you're looking at. But if you can remember the word identical, that kind of helps you out. So for a variable example, if we have parentheses x plus y plus 0, we're going to equal x plus y. Notice we started with the exact same thing that we ended up with. Okay, for multiplication, you would take parentheses a times b and multiply by 1, and that gives you a times b. Right, so you can tell that what you started with, you also ended up with, and that's your biggest clue. To make a numerical example, again, just take letters out and put numbers in its place. So we can have something as easy as 7 plus 0 equals 7, and negative 12 times 1 is still negative 12. Okay, so look for that plus 0 and that times 1 feature. The inverse property has some different names that you may not recognize from up here, but you may remember from your past experiences. The word inverse means opposite. So we're dealing with opposite operations. The opposite of addition is subtraction, opposite of multiplication is division. Right? So in the inverse property, a number and its opposite yields the same answer, and I'll show you what this means. Let's take addition, and you may also know this as the additive inverse property if you recognize those phrases, right? But for addition, if we take the letter x, we have to add to it negative x, because that's the opposite of positive x, and that will equal 0. Every time you take a number or a letter and add its opposite to it, it makes 0. So for the numerical example, you could have 7 plus negative 7. Those are opposites of each other, and those will equal 0. And again, that's also known as the additive inverse. For multiplication, okay, it may be known as the multiplicative inverse. The word that I'd like to help you remember that one with is the word reciprocal. If you can remember that reciprocal goes with this property, you'll have no problems. Right? So if we take the fraction x divided by y, the reciprocal means to flip the fraction, so now it's y divided by x, and that will always equal 1. Every single time that you do the multiplicative inverse property, your answer is 1. So in the numerical side, if we have 4/3, we have to multiply it by 3/4 to get that 1 to happen. And the reason this happens is because diagonally your numbers cross off. And when all your numbers cross off, you're left with 1 as your answer. Okay, so do look for those reciprocal pieces. The next property on the front side of your sheet is the multiplicative property of 0, or just what you guys probably know plainly as the 0 property. Okay? And you've probably known this one since about kindergarten or first grade as well. And it's as simple as this. Anything times 0 is 0. Doesn't matter what it is. Okay, so for the world of variables, I can put something as fancy as parentheses a plus b plus c. As long as I put times 0 in there, your answer is still 0. For numerical, I can take any combination of numbers. Right? I can negative 17, but as long as I do times 0, your answer is still 0. So those are all the ones you should have been familiar with from the past. If you flip your paper over, here's where some of the newer ones that we are going to spend a lot more time with in algebra, and that you'll have to actually make a little bit more effort to remember because you haven't seen them yet. Okay, the distributive property. When we distribute things, we give out or share it to other people or to other things involved. Right? So your distributive property, you are going to share the outside term with everyone inside. You cannot forget anybody. Okay, and we do this sharing by multiplication. So let me show you what this looks like. Okay. For a variable example, I would have an a on the outside of parentheses, and in parentheses I would have b minus c. In order to do the distributive property, you have to multiply that a to everybody in the parentheses. So we take a times b, and that gives you ab. Then we take a times c, and that gives you AC, and there's a minus sign in the middle. Notice how both pieces have the A in it because you gave the A to everybody in the parentheses. You have to make sure that happens. For the numerical example, okay, if I have a number on the outside and numbers on the inside, you're doing the same process, but it looks a little bit different because it's all numbers. Okay, if you take 4 times 2, you'll get your first piece, put your plus sign. 4 times 5, will give you your second part. And notice the 4 was used twice, so it's a big clue that that's what you're doing. Some problems will go a little further with this. They will take the same original problem you started with, and instead of leaving you with this statement 4 times 2 plus 4 times 5, you will actually end up with 8 plus 20. They do the multiplication already out for you. So just kind of watch out for either version of those. You're most likely to see the top one though for right now. All right, the newest ones are these last 3 in the chart. right? And these are the ones that if you've never stepped foot in an algebra classroom before, then these are your very brand new ones that you need to know from here on out. Okay? The reflexive property. I like to use the word reflection to help you remember this. Okay? And in a reflection, if you look in the mirror, you see your reflection, you're looking back at yourself. So you and you. Right? So the easiest way to know this is that the left side of your statement has to equal the right side of your statement. This is one of the easiest ones to recognize, but you have to remember what it's called. So for a variable example, it could be as simple as x equals x, p equals p. Or you could even go as fancy as x plus y equals x plus y. Notice no order changes and everything's exactly the same on both sides. For the numbers, same thing. 4 equals 4, -6 equals -6. So pretty easy to recognize with that one. The symmetric property involves the word symmetry, right? And if you can remember what symmetry was back from elementary school, if you take a picture or a shape and it has a line of symmetry right down the middle, you can fold that shape perfectly in half and everything matches. It's kind of what's going on in this property too. Okay? You are taking a statement and switching the values on the left and right. Now the nice thing about this one is there's some words involved that you will always see. So when you start seeing these words, you kind of have a big clue right away that you're at the symmetric property. Right, so the first one I'm going to show you is a variable example. For instance, if I tell you x equals y, then y has to equal x. Notice that it has the words if and the word then. Those two words must be there for it to be a symmetric property. And then notice that the only thing that happened was that the x and the y switched places with the equal sign. So for numbers, if a equals 3, then 3 also equals a. It's just taking the statement and reversing it around and putting the words if and then in the statement. For the transitive property, this one has 3 big words, and if you look for those 3 big words, you will always pick out the property and match it up correctly. You will see the word if, the word and the word then. And that clues you in that you're automatically at a transitive property statement. So it'll look like this. If blank equals blank and blank equals blank, then blank equals blank. And those blanks will be filled in the actual statement. So for the first example for variables, here's what I mean. If x equals y and y equals z, then we can safely conclude that x equals z. And notice it had those 3 components, the if, the and the then. That's what makes it transitive. So for the number side, if a equals 3 and b equals 3, then a equals b. Okay, so there's an example for those. Okay. The other 2 properties that are listed below that are not in the chart are not ones you're going to have to memorize as properties just yet. We will embed those in the next chapter when we solve equations, but they're worth mentioning at this point because they are an actual property. So the closure property exists if all numbers in the problem are from the same set of numbers. So for instance, if you have a whole number and you add another whole number to it, you will still have a whole number. That's an example of closure, so that one works. If you have a whole number and you try to subtract a whole number, you don't always end up with another whole number. Sometimes you get an integer, right? So we say we end up with an integer. This is not an example of closure, so this would not work. The only 2 operations that closure actually exists in is addition and multiplication. You cannot find closure property in any other operation. Right, and the last one that I want to touch on, and again I will expound on this one in greater detail in the next unit, is the properties of equality. There are 4 of them. There's one for addition, subtraction, multiplication, and division. Right, and this is what goes to the balanced approach when we start talking about balancing equations. Okay, and I'll show you what this looks like, and then we will use it more later on. So if I have the equation x minus 4 equals 8, okay, I don't really particularly care about the answer right now. It's how we're going to get to it. We're going to add 4 to both sides. Well, this adding 4 piece that you just did, that's known as the addition property of equality, because what you did to one side of the equation, you did to the other, and it was the same operation. If you multiplied to get to your answer, then you would have the multiplication property of equality, and so forth. So take this sheet, study your properties, come back with any questions you may have, and we'll see what we can do in terms of getting you squared away on all of them.